If y over x minus x squared y equals to 4, show that 1 over x minus x squared times dy dx equals to 2xy plus y over x squared. So let us copy down the question first. If you look at the first term here, y over x, we can use quotient rules because we have u divide with v. And for x squared y, we're going to use product rules because we have u times with the v. And for 4 here, we're going to use constant rule. And once we differentiate constant, it becomes 0. So now let us differentiate. So we know that quotient rule is vu prime minus uv prime over v squared. And for the product rules, it is uv prime plus vu prime. And for the questions, let us differentiate. So the v, which is the x, differentiate y with respect to x is dy dx minus u is our y. And for v prime, we're going to differentiate x with respect to x is 1. Divide with v squared, which is x squared, minus, put a brackets there, u, which is x squared, differentiate y with respect to x is dy dx plus the v is y, and differentiate x squared with respect to x is 2x. So now let us simplify this. There's a lot of way of doing this. It's either you equalize the denominator, or you may simplify this by doing this, like this. So if we have a minus b over c, we can split it into a over c minus b over c. So for x dy dx minus y over x squared, we can simplify as x dy dx divide with x squared. So we're going to get 1 over x dy dx minus y divide with x squared. We're going to get y over x squared itself back again, minus, let us expand this, x squared dy dx minus, because negative times with positive, we're going to get negative, and I rearrange it, become 2xy equals to 0. So let's collect all the dy dx and factorize. So we have 1 over x here and here, minus x squared dy dx equals to, so we're going to bring terms without dy dx to the right hand side. So positive 2xy plus y over x squared. So this is shown. That's it.